Lesson 52. All right, what we're doing here is what we've done before, just a little more complex. We still have the issue here of adding fractions that do not have the same denominator. And that is a problem, gang. We need to have the same denominator to add fractions or subtract fractions. So how do we do that with this? And we go, oh, what's the LCD? We need a common denominator. What do I do? Do these guys have anything in common? They kind of look like it because we've got two x's, but that's not to be confused with, when you have a plus sign, it messes everything up. So basically, we have two different quantities. So when that happens, and that's going to happen down here too, what you do is the LCD is this times this. So our LCD, our new bottom, is both denominators, the product of both denominators. Okay? So neither of these had, like, what goes into both of these multiplied wise. So we're dealing with multiplication, not addition. So we multiply them together, and then now we're going to do it again for the second. And we're going to figure out the new numerators. Before, the numerator was a, right? But we had to multiply x times x plus y. So we also multiply a times x plus y. Sorry, my voice is cutting out. It's I think we had a swim meet over the weekend and I'm losing it. Okay, so then here, originally we had b on top, but what did we multiply x plus y by? We multiplied it by x. So that's the new numerator. So that is the hardest part, this first step here. Now we go ahead and see we have the same numerator, or same denominator. We're going to add the numerators, but I'm going to go ahead and probably multiply out we're going to distribute that a through there. So if we take care of the top, we get ax plus ay, and then nothing changed on here, so it's plus bx, all over x times x plus y. And then I take a final look at it and see if any of these have, yeah, like if all of these had an x, I might be able to cancel that out, but they don't, and this is our final answer. Okay, same with this. Two completely different entities, so the LCD for that is going to be x times a plus b. Okay, for both of them. So that's the first step, figuring out the LCD. And then we go, okay, what did I multiply? So I'm just going to go ahead and write this. And I'm going to put it in a quantity. What did we multiply a plus b by to get, what did we do from here to here? We multiplied by x. So I'm going to multiply the top by x. And the c multiplies, over here we multiplied by a plus b, so that c also multiplies by a plus b. And you know you've done it right as if you cancel these and, or sorry, you cancel what you can and you're left with what you started with. So if I canceled those out, I back to c over x. So now I am going to distribute that through. So that might be hard for you to see. I'm going to rearrange this. I'm just going to rewrite everybody over the same denominator because they had the same bottoms now. Okay, then we're going to simplify the top by distributing through, getting rid of parentheses. So what that turns into is 4x squared plus ax plus ca plus cb, all over x times a plus b. And as ugly as that is our final answer. Okay, so find the LCD, figure out the new numerator once you give it a new bottom. So we're renaming fractions, adding the numerators together and putting it over the same denominator, getting rid of any parentheses in the top. For some reason we don't do that in the bottom, don't ask me why. And we add those up, and that's our end. Okay, so let's take what I just said and apply it to this. Find the LCD. Well, D is the same as D over 1. So we need the LCD of x, m, and 1. Well, the LCD is xm. Okay, we just multiply those two. So a plus b had to multiply by m to be renamed, and c already had the m on the bottom, so it multiplies by x, and d, to have an xm, had only a 1 on the bottom, so d has to multiply by xm. Okay, everyone has the same denominator now, and we're going to add them all up. However, if there's parentheses, we can get rid of those. Okay, so what we have is, usually I like to start with a first, and I'm checking right now, I'm looking over my shoulder to see, they leave it like this: m, a plus b plus cx plus dxm all over xm. And that's the final answer. Okay. All right, we've got a couple more. Now this one, again, the x just has a denominator of 1. So we have b plus c times k. That's gonna be our numerator. I'm sorry, tongue-tied. That's gonna be our denominator. So we're gonna go ahead and put, usually I like to put the single one in front, so k times b plus c. That's our LCD. So if we had an a and a b plus c was on the bottom, we actually multiplied it by k. So if we cancel those out, we're back to the beginning, right? If we cross out the k's, we're back to this, minus, and again, because he had a denominator of 1, he multiplies by everybody. So we're going to have x, k, b plus c. And let's think about that. If we canceled out what we could, cancel out the b plus c, cancel out the k's, we're left with x. So we know we've done that correctly. And then the last one was a k on the bottom, so now we've got to multiply d plus m times b plus c. Okay, so now we've got everybody over the same denominator, and we're going to leave it without multiplying anything through. So if we put all of these guys together, we're going to have AK, make sure you can see that, AK minus xk times b plus c plus the last numerator there, all over k. Okay. Okay, now we're going to totally switch gears and talk about overall average. Remember, average is adding everybody up and dividing by how many of them there are. So let's take a problem like this. The average of the first 90 numbers was 4, and the average of the next 10 numbers was 6. How many numbers are we finding the average of? We had 90 numbers were 4, and 10 numbers were 6. So how many? We have 100 total numbers, right? So, but the first 90 were 4, and the last 10. So we could do 4 plus 4 plus 4 plus 4 plus 4 plus 4 all the way up 90 times. Okay, plus 6 plus 6 plus 6 plus 6 plus 6 10 times, and divide that by 100. Now that seems a little ridiculous. So instead, what if we do 90 times 4, because there were 90 fours, and there were 10 sixes, and there were 100 numbers overall. That's going to give us the overall average once we multiply that through. So 90 times 4 is 360 plus 60 over 100. All right, so that's 420 over 100. I'm going to go ahead and cancel out our zeros because we love that. And so it's 42 divided by 10. Well, we know when we divide by 10, we have a decimal movement. So the decimal was here, and it moves over. So the average is 4.2. So think about it. If we had 90 fours and 10 sixes, the average is probably going to be a little over 4, right? And so that seems appropriate. All right, now we have 4, 3, I don't know, I'm guessing. We have practice problems. So go ahead and shut this off and see how you do on A and B. I believe those are the harder ones. And see if you get this. And if you don't, please call me right away. Email me or text me if you're not understanding how we make equivalent fractions with a new common denominator. All right, and you may begin. Okay, so I'm going to go ahead and put a 1 down there. So ym is going to be my denominator. I could even just write it here. Okay, so I take my first fraction, and the y stayed, so I'm multiplying by m, so I multiply the top by m. Here I multiplied 1 times x, or the 1 by ym, so b multiplies by ym too. For here, I had the bottom multiplies by y, so we multiply the top by y. Okay, and then to finish this, I'm curious, I think the solution manual is just going to keep it like this. We have xm minus bym plus y times c plus d all over ym. And there we go. Okay, the next one. It looks like our denominator is going to be b times a plus b. So we would have b times a plus b. And I'm just going to write it 3 times. Okay, well, that was the same, so we multiply the top by b. Okay, and it looks like we multiply the top by a plus b. And on this one, we multiply the top by everybody. And there we go. And then if we put everybody over the same denominator, we have now I haven't looked in the solutions manual to see what they have. So that is one way to finish it. They might have taken it a step further and multiplied b times everybody inside and x times everyone inside and this times everyone inside. I don't think they did, but if they did, I'm just going to take it one step further because I haven't, like I said, I'm not sure what they were looking for. And they left the bottom like this, and we multiply the b times everybody inside, which would be 5b squared plus cb. Then the x times everybody, and then the cb times everybody. So yeah, b squared. Can you see that? cb squared. That might be what the solution manual says, but I have a feeling they left it right here. Again, call or text if you get stuck on that. Now we've got the average of the first 5 weights was 10 pounds. The average of the next 10 weights was 25 pounds. So it's nice to know how many total we have. We got 15 total pieces of data. So the first 5 weights was 10. The next 10 weights was 25. And we want to know the average, so we put it over the top. So these should add up to 15, which they do. So now we got 50 plus 250 over 15, which is 300 over 15. Well, 30 divided by 15 is 2, so it's 20. And that is the average. So you got to think about it. 10 pounds and 25 pounds. That does seem like a good, appropriate average for all 15 pieces of data. Okay, I'm going to cut out there because my voice is missing, and I'm sorry that it wasn't too exciting for you today. Again, call or text or email if you get stuck.